lead time pooling, consolidated distribution. So this is the first topic on lead time pooling. We have two types of lead time pooling. The first of them is consolidated distribution, and this is an alternative to location pooling. And the second one will be delayed differentiation, and it will be an alternative to product pooling. So consolidated distribution is trying to address location pooling weaknesses. In location pooling, the key weakness is inventory is moved away from customers, right? However, positioning inventory near customers is costly due to uncertainty involved in allocating total demand to individual customers. So instead, we will use consolidated inventory and consolidated distributions. Distribution, which will try to keep inventory close to customers while hedging against this uncertainty of dividing the total demand over individual customers. So consider an example similar to the Medtronic InSync pacemaker case, but the starting system, the current system, will not have a distribution center, will just have supply directly from supplier. So suppose we have 100 stores or 100 territories with sales reps, right? Weekly demand in each store is Poisson with mean 0.5. And standard deviation is, of course, square root of 0.5 if it is a Poisson distribution. And assume target in-stock probability in each store is 99.5%. So in the current system, we have direct delivery from the supplier to each store. This is the top picture here. Current system, supplier delivers to each store directly 100 stores, 8 weeks of lead time between supplier and the store. And the proposed system is here, the lower part of this figure, right? So we have one additional centralized inventory in the distribution center, or DC for short. Now the lead time is from supplier to the DC, it's still 8 weeks, right? So this DC is somewhere close to those stores, somewhere in between those stores. And the lead time from the DC to each store is 1 week, right? So there are 2 lead times instead of 1. If you like, the total lead time is now 9 weeks, right? 8 weeks to the DC from supplier, and then another 1 week from DC to store. We're going to assume that in our proposed system, the demand in the DC is normally distributed with mean 50 and standard deviation 15. Now notice that if the demands in stores were independent, the sigma here should be around, sorry, this is a mistake, around 7, right? It should be around 7, which is square root of mean 50. However, in fact, we will assume that there is some evidence of positive correlation between demands in stores, and this is actually usually true if you have demands in different stores. If something sells well in one store, the same things normally will sell also quite well in another store. So because of this, because of some positive correlation between those demands in stores 1 to 100, instead of sigma 7, we will assume sigma is 15. And then we will try to evaluate the current system and compare it with the proposed system. So the evaluation of both systems will be done using the order up to model. And notice that in the current system, there is basically one order up to model for each store, ordering from the supplier with 8 weeks of lead time. And in the proposed system, there will be an order up to model for the DC, ordering all the demand for the stores with 8-week lead time, but storing it in one inventory rather than multiple. And then there is another order up to model for each store that is the same as before, except for lead time. The lead time for the store now from the DC is 1 week rather than 8 weeks directly from the supplier. So if we evaluate both systems, of course, right, we will have the current system results shown here, proposed system consolidated distribution shown here. And for comparison, I have also location pooling, right, which we are trying to say that, has certain disadvantages, and consolidated distribution might address some of the benefits, get us some of the benefits of location pooling without the disadvantages. So let's first look at the current system. And all I'm showing here is the on-hand inventory at stores, expected on-hand inventory in stores, but the total. So the total is 650. And how did I obtain this? Well, I solved the order up to model for each store. I obtained a certain order up to level S. And then I calculated the expected on-hand inventory for one store, and it was 6.5 units. So that means that the total inventory in 100 stores will be 100 times that, so that will be 650 units. And notice there's no distribution center in the system, right? And so no pipeline inventory between DC and the stores, right? Because of that, this is the only inventory. The total is 650. Now, if we don't have all the stores, instead we go for the extreme location pooling like an e-commerce solution, right? We just have the DC, but we don't have the stores. So the inventory in the stores is not existing here, right? Of course, there are benefits here because the DC will be a single inventory for a combined demand. This is the benefit of location pooling. And even if there is some positive correlation between those demands, the benefit will still be very large, right? So we see here all the demands of the stores are combined. The lead time is still 8 weeks, but an order up to level will be determined such that the end of expected on-hand inventory at the end of the period in the DC will be much smaller than 650, the total inventory in stores. So this is a great benefit. Now, let's see what consolidated distribution gives us, the proposed system. So the first thing to realize is that the DC in this consolidated distribution will have exactly the same order up to level as in the location pooling. It is still ordering from the supplier with 8 weeks of lead time for exactly the same demand distribution. So there will be exactly the same expected on-hand inventory at the distribution center. But now, of course, the stores still have to keep their inventory. So this number is not zero. And now the reason it is much smaller than here is that in this solution, the stores have much smaller lead time. In the original system, they had lead time 8 weeks. Now they have lead time 1 week. And so they have much smaller order up to levels and then end of period inventory level at each, on-hand inventory at each store is just 3 units, 3 times 100 stores. That's 300 in total, right? So we have this additional inventory compared to this case. There was no DC, now there is, but the store inventory, in-store inventory is decreased by more than 50%. Now, however, notice that the total lead time in this solution is 1 week longer, right? Here, the lead time was 8 weeks directly from to stores from the supplier, right? From supplier to stores. Let's put this to stores, right? To stores. In here, there's still 8 weeks of lead time. It's directly from the supplier to the DC, right? But in this case, we have 8 weeks of lead time from supplier to the DC, and then another 1 week of lead time from DC to stores. So there is an additional 1 week of lead time. And if you recall, pipeline inventory is average demand times lead time. So there is an extra week of lead time. Therefore, we need to add extra pipeline inventory. And remember, the total demand for all stores is 50. So there will be another pipeline inventory of 50 units, right? So this we also have to account for. And when we add those three, we get the total inventory in the system, in the stores, in the DC, and the extra in the pipeline compared to the other cases is now 466.07. So comparing those numbers, you see it's better than the current system without the DC, right, where all the 100 stores order separately from the supplier. This is better, not as good, actually far from location pooling, but avoiding all the disadvantages of location pooling, such as right keeping inventory far from customers or not letting the customers see the product, evaluate it, try it on, or see if it's fresh, right? That we have when we have stores. So to summarize this, you see we reduce total inventory by about 28%, right? This is about 28% less than the system without the distribution center. So consolidated distribution brings us some benefit in inventory reduction, not as effective as location pooling, right? Not as effective as this, but at least it keeps inventory near the demand. right? So avoiding additional shipping costs to customers and avoiding other problems that are related to having the inventory far from customers, right? Notice also that even though this is just 28%, the retail shelves inventory is reduced by more than 50%. This, just comparing this 650 to 300, this is a significant reduction. And remember, shelf space is more expensive than space in the DC. So, right, somewhere on the trucks or somewhere in the DC, the space might be right less expensive than the shelf space. Shelf space is the high-priced space, right? If you have to, because the rental cost for the space in retail is much higher than the rental cost for some warehouses that can be far from most populated areas, right? And notice that the inventory reduction here exists despite the fact that we have increase of the total lead time from 8 to 9 weeks. So, right, and lead time increases. Normally, the pipeline inventory increases, but despite that, we still have a reduction in the total inventory that we carry. So, why is this actually called lead time pooling or lead time risk pooling? Well, you can see graphically that those lead times, 8 weeks, are like separate lines here, right? And in the proposed system, we kind of keep them together for longer, right? Before we let them separate. Okay. So in fact, it's not really lead time pooling, it's demands of those stores that are pulled together or kept together. But it is accepted as a term in literature. So we have to kind of get used to it, right? It is normally called lead time pooling because those separate lines are kept together for longer time. And that's why this is called lead time pooling. And of course, this is one type of lead time pooling consolidated distribution. We will also discuss another type later on. So you see that consolidated distribution reduces inventory in the supply chain via lead time risk pooling. In other words, a supply chain only needs to decide the total quantity to ship from supplier to the DC, not the quantity that it will allocate to those stores later on, right? Therefore, some uncertainty is avoided, right? So we can delay the dividing the total demand between the stores because we deliver it to the DC that sells all the stores, right? It is, of course, most effective if negatively correlated demands occur at locations, right? But even if it is somewhat positive correlated, it might have benefits as we showed here, right? This was a case of some positive correlation, not perfect, right? And of course, most effective if supplier lead time is long and DC to store lead time is short, as we had in our example, right? Supplier to DC lead time was 8 weeks, and DC to store was just 1 week. But notice that it increases the total distance that is traveled, right? And the total lead time from 8 to 9 weeks was also increased. There are other benefits that you can have from consolidated distribution. So one is you can obtain quantity discounts when you purchase, right? If all those stores purchase separately, going back to this example, if all the stores here order separately from the supplier, they may appear like small customers, whereas here the DC will make a large request and that may have some discounts or right some better power in negotiating the price. And also it's easier, of course, to obtain economies of scale for the same reason, right? There's one big shipment to this DC, right? Whereas stores might require much smaller quantities delivered to them and less than full truckloads, for example.